Hello guys, today I am going to explain LeetCode problem booking concert ticket in groups. In this problem, you will be given two cases. In case 1, you will be given a group of spectators. You have to choose consecutive seats for them in a row. And the row number should be minimum as possible and the row number should less than or equal to max row in gather function. And another case is the group of k spectator. Here they may or may not sit together. That means you may or may not choose consecutive seats for them. You can choose as many as row required to allocate seats for the k spectators. But the row number you choose must be less than or equal to maximum row in scatter function. So I solved this problem using segment tree. If you don't know segment tree, please learn it first and then you can watch this video. And if you know segment tree, you can watch this video. Let's move to the solution. Here I use two segment tree. One is maximum tree. The tree will save the maximum available seats in a given range, and the sum tree will save the summation of available seats in a given range. Here I build the tree using this build function, and the function is called from book my show. Here I set the row and column, then build and call the build function. Now move to the gather function. In gather function, I take answer from query function. In query function, I just return the leftmost index which value is greater than or equal to k. K means the required seats, and in this function I just search the leftmost index which value is greater than or equal to k. If I don't find any index, I just return a huge value, and then in gather function I compare the index number or row number with maximum row. If the row number is greater than maximum row, I just return empty vector. If not, I return the row number and the seat where I assign this k spectators. As I assign k spectators, I must update the tree. So in update function, I update the max tree and sum tree. I just subtract k from the max tree and sum tree node. Now for scatter function, I take answer from query to function. In query to function, I choose leftmost indexes whose summation is greater than or equal to k. Look, we need k seats, and the row number should be minimum. The rows you select should be minimum as possible, so I must choose from the left tree. So here I take the left tree value and right tree value. If left subtree is greater than equal to k, I query in the left subtree. Otherwise, I simply minus left subtree value from k, because here we are assuming that we have already taken the seeds in the left subtree. So I simply minus those seeds value from left subtree in this uh, else condition. If now here when we found those leftmost indexes, I just return them. If I can not found any indexes, I return a maximum value. Now in scattered function, as I told earlier, that the row number you select, the rows you select must be less than or equal to maximum row. So I check it here. If the rows number are greater than max row, I return false. Otherwise I return true. But here you have to do additional work. Look, if you choose, let's assume that for a test case you choose 4 leftmost rows whose summation value is greater than k. So while you assign k in these rows, the first 3 rows will become 0, must be 0, and the last rows may be 0 or may not 0. So I check the k value of k. If k is 0, then the last row I select also 0. Otherwise I update the last index or last row by subtracting k from it, and the other rows I selected first will update with 0. Now here I take track variable, which I declare in the top. The track variable will track that how many rows I have already updated with 0. If I already update them with 0, I need to update them again. So I check the rows number which are greater than track and less than z, and update them with 0, and then just I update track value and return true. This way you can solve the problem. The problem is a hard level problem. So if you want to solve it using segment tree, you must solve some easy problem in segment tree. Then you can try it. Okay.